Hello class and welcome to today's lesson on 8.4. We're going to talk today about angles of elevation and angles of depression. So our objective today is to use angles of elevation and depression to solve problems. Essential question is, how do I use angles of elevation and depression to solve those problems? So starting off today, right, what are angles of elevation and angles of depression? So right, an angle of elevation, if we look at this picture here, is this angle X. Because notice from the person's point of view, there's this horizontal line, and he is looking up towards the plane. This is going upwards, so we call this an angle of elevation. Right? He's looking up towards that airplane. Now, if we're looking at the horizontal line and focused on the boat, notice this angle Y here is going down. We call this an angle of depression because we're looking down at this from this horizontal line and it is coming down below that line. That's right, we kind of just talked about this. Angle of elevation is the angle between the horizontal and the object above it. And an angle of depression is the angle between the horizontal line and an object that is below it. So again, if you need to pause it on this slide, please feel free to do so. Right, angle of depression is not a sad angle. It is not a sad angle. It is meaning an angle that is below the horizontal line. Below the horizontal line. So what we're going to do is we're going to use what we've learned earlier in this chapter, right, using some trigonometry here to help us answer some questions. So first one here. We'll use these angles and trig to solve for unknown lengths. Right, we're given the picture where we have this airplane, angle of descent is 3 degrees, and it says how far is the plane from the airport if it is 28 miles away horizontal. So we can set this problem up two separate ways. So what we can do, right, it's saying this distance here, whether you want to focus on it on the ground or in the air, is 28 miles away. 28 miles away. And now what we are trying to do is we are trying to find this measurement right here in red. We're trying to find how far away is that airplane from the airport. So what we're going to do is we're going to create a triangle. Right? You could focus on the triangle that it makes right here. I'm going to recreate the triangle down here. Right? It makes a right angle there. What we know is that if this is 3 degrees, this angle of elevation from the airport to then the airplane is also going to be 3 degrees. Right? Those are the same value. Right? You can think of those as parallel lines, and those are alternate interior angles. So we have this information. What we need to do is figure out what is this distance. Well, right, if we think of this triangle right here that I'm highlighting in green, what we're missing, what we're trying to find is the hypotenuse of that triangle. What we have from our angle that we're given is the adjacent side. So if we have the adjacent side and the hypotenuse, that should tell you right away we are going to use cosine. And right, we always set up these equations as cosine, or trig function I should say, of our angle is equal to our fraction, whether it's opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So looking here, we have cosine of our angle. Well, we know our angle is 3 degrees, is equal to, right, SOHCAHTOA, right, for cosine it is adjacent over hypotenuse. The adjacent side is 28, the hypotenuse is unknown. So what we do on one like this, right, we can flip these two, and our hypotenuse is going to be equal to 28 over the cosine of 3. And now what you need to make sure to do on your calculator if you are doing this is make sure that it is in degree. Make sure that your calculator is in degree. So if I take 28 and divide it by the cosine of 3, I find my answer for my hypotenuse is 28, and we'll round to 2 decimal places, 0.4 miles. 28.04 miles. So moving on to the next one here. Right, we have this tree here. We're trying to find the height of the tree using the angle of elevation to the sun, from the ground to the sun. And so it says the angle of elevation is 29 degrees. So that means this angle right here, this theta, right, we use that Greek letter, right? Theta is 29 degrees. What we are trying to find is the height of this tree. So let's think of it in terms of our angle. From our angle here, the tree is the opposite side. Right? The tree is the opposite side. We are given the adjacent side. We don't have to worry about the hypotenuse. So if we have opposite adjacent, right, that should tell you tangent of our angle equals a fraction. Okay, so now we start plugging in some information. Tangent of our angle, well, our angle is 29 degrees, is equal to, we know SOHCAHTOA would make it opposite over adjacent. So we do our opposite side, which is unknown, over our adjacent side. Right, not to be mistaken, right? It's not a 0, right? Opposite side over 12. So we're trying to solve for this. So what we need to do, right? We multiply both sides by 12, and we're going to find our answer. Right? The length of that opposite side, we multiply 12 times the tangent of 29, and we get an answer of 6.65, and our unit of measurement would be feet. So the height of that tree is 6.65 feet. And we got one more example here for today. So can we use trig to find the angle of elevation, which we are calling theta in this case? So I notice our 2 examples so far were a little different. This third one now is again a little different here. Notice we are given some side lengths of our triangle, and we need to find our angle theta. So what we need to do is focus on theta, is this angle here. We think about the sides we are given, right? This tree is our opposite side. The shadow down here is our adjacent side. So just like the one before this, right? If we have opposite adjacent, we have tangent of our angle equals a fraction. So now we start plugging in our information, right? What's different about this one? We don't know, right? We have theta here is equal to, so tangent of theta is equal to our opposite side. Again, one more review here, right? SOHCAHTOA, opposite over adjacent. Be our opposite side over our adjacent side. So now what we have to do is we have to remember, how do we solve one like this if we do not know the angle? All right, when we're dealing with trigonometry, we have inverses of all of our trig functions. And right, we use the inverse of a trig function if we don't know the angle. And so to find this information, I'm going to take tan inverse of 50 over 60, and that will give me the answer for theta. So in my calculator, right, you hit second tangent, you do 50 divided by 60, hit enter, and it is telling me that theta is equal to 39.81 degrees. Right, that is the angle of elevation from the shadow to the top of the tree. So that is it for today's lesson on angles of elevation and angles of depression.